Write down the balanced chemical equation representing the reaction of an alkali metal, M, with water. Both lithium, Li, and potassium, K, are group 1 alkali metals and react with water in an identical stoichiometric ratio. 2M plus 2H2O gives 2M to the power plus 2OH to the power negative plus H2. This equation shows that for every 2 moles of alkali metal consumed, 1 mole of H2 is produced. Recall the relationship between mass, molar mass, and moles. The number of moles, N, of a substance is determined by dividing its mass, M, by its molar mass, Chem. N equals M over Chem. Compare the molar masses of lithium and potassium using the periodic table. Molar mass of Li, approximately 6.94 grams per mole. Molar mass of K, approximately 39.10 grams per mole. Calculate and compare the moles of metal present in each 0.35 grams sample. Moles of Li in the first experiment. Li equals 0.35 grams over 6.94 grams per mole, approximately 0.050 moles. Moles of K in the second experiment. Nk equals 0.35 grams over 39.10 grams per mole, approximately 0.0090 moles, because potassium has a much larger molar mass than lithium. 0.35 grams of potassium contains significantly fewer moles of metal atoms than 0.35 grams of lithium. Relate the moles of reactant to the moles of gas produced. Since both metals react with the same stoichiometry, the reaction with fewer moles of metal reactant will yield fewer moles of gaseous H2 product. Moles of H2 from Li equals 1 over 2 times 0.050 moles equals 0.025 moles. Moles of H2 from K equals 1 over 2 times 0.090 moles equals 0.0045 moles. Conclude the overall effect on gas production. Because the 0.35 grams sample of potassium contains far fewer moles of reactant than the 0.35 grams sample of lithium, a much smaller amount of hydrogen gas will be produced when potassium is used, which corresponds to option B. The correct answer is option B. Some gas will be produced, but less than the amount of gas produced with Li.